I'm going to put up just a couple more problems here. This is more like just notes for you if you need help on especially the solving. That would be section 7.6. And then I'll do one more graph as well. So hopefully, this will be okay. Let's just try a couple from 7.6. That's the solving equations, radical equations. So let's try one, I don't know, something like this. 3x to the 4/3. And that's going to equal, let's say, 243. Okay, so to solve it like a regular equation, if this was just 3x equals 243, you would divide out the 3 first, right? So that's what I'm going to do here. Divide out the 3 first. So that's x to the 4/3 equals, do this in your head. How many times does 3 go into 24? 8. 3 go into 3, 1, so that's 81. So now I'm left with x to the 4/3 equals 81. Well, how do you undo the 4/3 power? Raise it to the 3/4 power, of course. So then I must do that to this side as well. So that's just going to become x to the 12 over 12, or x to the 1, or just x. And that's going to equal, remember now, this is the same thing as having the 4th root of 81, which you should know is 3. Good. And then cubing that. So that would be 3 cubed, or 27. So that's, just a basic example there. Let's do a little more challenging one, but not a whole lot more, but let's try it. These are not answers to any of the questions. These are just more notes on that last 7.6. I know we did that on the Friday before we left, and we didn't do it enough. I wanted to do it for 2 days. So I'm just giving you some more examples here to try to help you with the last section in the chapter. So let's do the square root of 2x plus 8. And then it says, let's see, minus 4 equals 6. Well, once again, obviously, the first thing to do would be what? Think about it. This guy, move him over here. So then I'll end up with the square root of 2x plus 8. Moving the 4, I'll get 10. Well, I got to square both sides since I've isolated the radical sign over on this side. So I'm just going to square this side. So I got to square that side. So that is just going to be 2x plus 8 equals, well, 100. And now it's just a very basic problem. 2x equals 92, subtracting the 8. So x is going to equal what? 46. Now, we should check that, of course, because I've squared both sides. I might, there might be no solution to this. You never know. So put 46 over here, right? So look what I've got here. 2 times 46 is 92. That's 92 plus the 8. So you end up with 100 in here. The square root of 100 is 10. 10 minus 4, it is 6. So that is, in fact, the answer. Okay? I'll try maybe 1 or 2 more, and then we'll go to town with that. Let's try one that's a little bit more challenging. Square root of 4x plus 28. Okay? Minus 3 times the square root of 2x equals 0. Well, remember what we said. We're going to try to get the isolate one radical sign on each side, yeah? So I'm going to take this guy right here and move it over yonder. So then I'd end up on the left side with just 4x plus 28, and that's going to equal positive 3 times the square root of 2x. Now that I've got it isolated on both sides, the radical sign, I'll square both sides, right? So I'll end up with 4x plus 28 equals, don't forget, that 3 is going to be squared. So that'll be 9 times 2x. Square root of 2x squared. So that'll be 18x, right? So I'll have 4x plus 28 equals 18x. Subtracting the 4x, I'll get 14x here equals 28, which means x should equal 2. But we should really try to check that just to make sure in the original problem it's going to work. So if I put 2 in here and here, I should get 0. So on this side, if I put 2 in here, 4 times 2 is 8. 8 plus 28 is 36. And the square root of 36 would be 6. If I put 2 in here, I get 2 times 2, which is 4. The square root of 4 is 2. 3 times 2 is 6. And 6 minus 6 is, in fact, 0. So that means that is the correct answer. Okay, so I'm going to try to do one more graph for you guys, if I can. We'll extend the page here. I'll try to put a graph on here just to kind of remind you how, excuse me, how to do that graph. I don't know why that didn't come up. I don't know. It's not coming on my graph. So that's, oh, there it is there. So I'm going to do it here. Okay? Happens here. Okay, so I'm going to just graph one of these ones that we graphed from, I don't know, back a couple chapters or a couple sections ago, if you recall. Maybe we'll graph one, I'll graph a cube root one or square root one, I don't care. Why don't we go ahead and do this one? Cube root of x minus 7. Cube root of x minus 7. Now, if that is your function there, remember the cube root, and that's a positive cube root, it's going to look like that. And what's that minus 7 going to do? It's going to shift everything down 7, right? So remember, whenever you're doing these graphs, I'm going to do just the cube root one, and if there's a coefficient out front, I would leave that there. Because I know what numbers to put in for cube roots, because we've memorized our cubes through 10, haven't we? So I would certainly do 0. I would do 1 and 8, because those are perfect cube numbers. But remember, for an odd power, or odd root, excuse me, I can do the negatives as well. So if I put 0 in there, I get 0. If I put 1, I get 1. Just here now. Remember, this is just doing the cube root of x. I'll do the 7 afterwards. 8, I'll get 2. Negative 1, I'll get negative 1. Negative 8, I'll get negative 2. So if I was to graph this, 0, 0, I've got 1, 1, and 8, 2, and negative 1, negative 1. This should not be a surprise to anyone. Now, I would, if that 7 wasn't there, I'd be done right here. And of course, the domain is all real numbers here, and the range would also be all real numbers. However, because I have this minus 7 there, I got to move all these points down 7, yeah? So I'm just going to take this point, just move it down 1, 2, 3, 4, 5, 6, 7 to here. I'm going to take this point, 1, 2, 3, 4, 5, 6, 7. This point down 7. This point down 7. And this point down 1, 2, 3, 4, 5, 6, 7. So my final answer would be here. But once again, the domain is all real numbers and the range is all real numbers. So that's like a graphing one for a cube root. See if I have a different one up here. So I'm gonna go ahead and just do a square root one as well. So you can reread that or look at this part of the video if you need to. But I'll do a square root one now, okay? And we'll try, I don't know, let's try a fairly difficult one. I'm trying to find one that's a little more challenging for us. All right, let's do this one. Y equals negative 3 times the square root of x minus 2 plus 1. Now remember, we could think a lot about this even before we started, right? It's negative and it's square root. Remember, mama of square root look like this, yeah? So the negative one's going to look like that. It's also going to move 2 to the right and 1 up. So when I'm done, it's kind of going to, 2 to the right, 1 up. I mean, it's probably going to look something like that or whatever. But we'll see. But once again, what do we do here? I'm just going to graph as if the problem was that, because I know all my perfect squares. So I'm going to go ahead and graph this. What numbers are you going to use in there? You cannot use negative numbers, remember, because that would be imaginary. So I'm going to use 0, 1. Don't forget the 0 and 1. A lot of you guys forget that one. And of course 4, 9, maybe 16, but it doesn't fit on my graph. So let's just see what we get here. If I put 0 into here, that's negative 3 times the square root of 0, which would just be 0. So I would have 0, 0. If I put 1 in there, I'll end up with negative 3. So at 1, I'm at negative 3. See how it's going steeper than mama because of the 3 here? Remember, if I put 4 in there, that's 2, that's negative 6. So at 4, I'm already down to negative 6. When I put 9 in there, I'll be at negative 9. So at 9, I'm already down to negative 9 here. So I won't use 16 just because it doesn't fit on my graph. If it did, I would. Now remember, I would be done if, if that was the whole graph, the whole thing. But we still have to deal with that negative 2 and that positive 1. So I'm going to move the negative 2 to the right and 1 up. Each point goes 1, 2 to the right and 1 up. So that's the actual point. This point here, 1, 2 to the right and 1 up. This point, 1, 2 to the right and 1 up. And finally, 1, 2 to the right and 1 up. So my final answer would be something like that. Now let's talk about the domain and range here. Remember, cut off the graph where it is. You don't see any x values over here. The reason is because if I put any number in there, even like positive 1 here, if I put positive 1 in here, this square root sign would end up being negative 1, which is an imaginary number. So that means the domain cannot handle negative or positive 1 even. It can't handle any number down here. So my domain of this problem would be starting at and including 2 and going all the way to positive infinity. My range of this one, again, that would be this way around, right? I do use negative or positive 1, and it will go all the way down to negative infinity. So hopefully with these, we'll just keep on working on these things. And I'd like you, when you're done with that review, I would like you to try the chapter test on page 459. And I will post the answers to that either tomorrow or the next day. I'll email you all and tell you to do this as well in case you're not watching this video. Okay, guys, so keep emailing me with questions so that I can do the video. I'll come in again tomorrow, and I'll do any questions that you want to have out of Chapter 7. So look through all the sections of Chapter 7 and let me know. Okay? Thanks, guys.